All right, so let's get this going here. This will be an extra um, little bonus stream that we'll kind of probably tie in over on the YouTube side. But this is something that in the first week of the Linux Systems Administration course, we put together. I had everybody just send me in, the jobs that they were interested in. What I did was I went and I grabbed all of them out. Not all of them, but most of them. And here's all the tasks that were being asked for over here. I know that's a lot. Don't worry about it right now. We're just going to start going through them and looking at what we know. We're going to start on one that we've done before, and then we'll kind of work down into those other ones. But these come from an actual job board requirement. If anybody wants to hop into a lab and do some killer or some Linux shell with me, I always tell you guys if you're trying to learn something, you got to have your hands on it, right? So you got to spend some time in here. So I would get at least at a Linux shell whenever you're hanging out with me, or some kind of notes. How's it going, Control Byte and Sanji over on the Twitch side? We are talking about actually getting a job, like getting. I've seen layoffs. I've seen more and more layoffs just the last couple days, and just we keep seeing tech rumors of more layoffs coming. So what I kind of wanted to do was for people that want to go the route of being a Linux systems administrator and moving towards that engineering role, we're just going to look at some of the stuff that's actually on the job boards out there, right? And what I did strip out I don't have the link. So if you're looking for the link, you're just going to have to go to Dice and LinkedIn Jobs and stuff where all these were. If you want to know where they're at, if you're just like really curious, they are all here in the in our Discord under our Prolog projects. There was a discussion post 1. Actually, it was 2. And discussion post 2, people were just posting job things. So I went down through most of them. I don't even think I grabbed all of them. But what we're going to do is we're going to look over here on the right at what somebody was asking for, and then we're going to talk about it in a Linux system as much as we can. Maybe we'll pull up some different links. Maybe if we pull up some links this time, we'll throw those into this doc, so this doc becomes a little more complete. But when I originally did this, I did it over in Notepad++, so that's what we'll be using. You can also use, if you want to use something like Logsec, you've got that. If you want to use something like Obsidian, some of you guys really love that tool, use it, right? Do whatever you guys want to. But this is probably just going to be a little bonus part of the Linux Systems Administration course that we're running right now down in our Discord. Discord's always free. I'll post a link to that. We're almost to 3,000 people, which is wild because we were barely hitting 1,000 in March. So, Lord Processor, thank you, Scott. Please, how can one access your notes? Go down in the Discord, and most all of my stuff is right over here in the resources somewhere. And this talk will be part of the Linux Systems Administration course. We've got a 16-week course we're running, and this will be put in as one of the. It'll be like basically track 3, and then we'll go in next week. Will be unit 3, right? Because we're going through all the different units. And we've got a whole syllabus set up, and you guys can study and do as much or as little of that Linux stuff as you want. Hey, Honorable, how's it going? All right, so the first question, the first thing you got to know how to do is install, configure, and maintain Linux operating systems. Red Hat, CentOS, Ubuntu, software applications. Okay, so how might I do that, right? So if I need to add tools to something that's already there. So let's go into my home lab here. Let's do something that I haven't shown you guys lately in a while. But let's go over here, and let's say that I were to just... I think this box has some extra space. Yeah, this box has some extra. So I'm just going to right-click on this and say, I just want a new virtual machine, right? This would be the equivalent nowadays of if I were just to pull a machine out of... let's say I was just going to pull a machine out of an actual crate that they sent over to me, and I'll just say stream, build, or something like that. I'll call it stream build. And when I go through this, right, as a virtual machine, because virtual machines are different than physical machines in that they don't actually get elevation somewhere in a rack. There's no documentation to where we actually racked this. I can come over here and I can say, okay, well, if I were actually pulling a real physical server out, I might go put an ISO into it. Back in the day, it was through like a DVD player. Nowadays, it tends to be through like a USB on the front of that device in some way. So I come over here and I say, okay, when we load this up, let's go ahead and use this. we'll go ahead and build this as a Kali box. We haven't built a Kali box in a while, right? So I'll go throw Kali on it, right? And then maybe because of that, I'm going to back it up a little bit and say stream build Kali, maybe. And maybe I'll put an 01 on it because I expect to make between 1 and 99 more of them, right? So then I go here and I say, okay, it's going to be there. We're going to do a BIOS boot. That's fine. The home server, it's going to exist on this server, which has 29.3 gigs of RAM available right now, and I'm going to hit that. And we'll give this Kali box a little bit of heft. It'll be 4 CPUs, and let's go ahead and make that 8 gigs of RAM. Good, boom. And that's just, you know, speaking to how much processing and memory we're going to have on the box. And then storage, 10 gigs is a bit small. I would say the minimum nowadays is maybe like, let's just say, let's give them 50 gigs. But we could put them over on lab storage where we have 375 gigs free, or down on local storage where we have 133 gigs free. Let's go ahead and put them on lab storage because we got a little more space out there. Those are a couple of RAID 5 arrays between the two of them, right? And then we come down here, and we're going to let all the networks be there because there's 4 networks that can come in there. We can review this, and we'll just go ahead and say create now. We'll leave it as Red Hat Enterprise. Actually, we want to change that. Since I changed the disk that I was building, let's change that here in the template, and let's change, because it's mostly since we picked a Kali box, Kali is more like Kali is probably more like Ubuntu than any of these other ones here. So we'll go with we'll just call it Ubuntu. That's fine. It doesn't really matter what's underneath the hood there, but we'll say stream build Kali 01, right? And this name is yeah Ubuntu Debian, pretty close, yeah. So we'll just run that. We'll put Kali back, right? And again, these come from an NFS share that I have, so we'll just go ahead and go with the most recent Kali because that's what we're playing with. We'll give it all the same stuff. I can't believe these things reset. That is some crappy design. Whatever, 8192 if we're gonna do that. And if it's gonna convert to megs, we're gonna switch it that way. And then we're gonna make this bigger again. Gosh, I can't believe this is weird. But we're gonna take it 50 gigs, okay? And then we'll give it the same networking, and then we'll go and we'll build that box out, right? And again, we're looking at an actual job requirement that somebody has that you need to be able to install, configure, and maintain Linux operating system. So in this type of task, if we were building this from scratch, we could build a machine maybe for the first time. Then after we build it for the first time, we tend to then save things as some kind of golden image or some type of template, and then we can just deploy from the templates. And you guys have seen that I have Ansible playbooks where I can just deploy from this template and make a whole bunch of systems in my environment, right? Whatever kind of systems I want. But in this case, you know, we're going to go to the console now, and we're going to watch the system boot up. And it's graphical install or advanced options if we want to go change anything about the system. But let's go ahead for now and just say, well, we want to do a graphical install. And I don't know what Kali uses as its installer, but we'll see here in a second. A very common type of installer you might run into in the Red Hat world and SUSE world is the Anaconda installer. And, oh, did that not take? That's just taking its time. Yeah, should be coming up here soon. Oh, why that's taking so long. But anyway, so to install a system, what do we have to do? We have to have some type of connection to the server. We've got to upload some type of ISO file or get it to Pixie boot over the network, which is how most of my other boxes boot in the environment, right? We just boot and they pull down a new ISO image from the Werewolf server or whatever. And this thing's having a build problem. Oh, that's interesting. It's not able to mount on XVDA, so we might have to pick when we go. Let's go ahead and hit continue. We might have to change some things about how it's trying to automatically mount and all that kind of stuff. So we'll let it install and do some little stuff that it's going to do, and then we're going to get dropped into a kind of prompt of all the different things that we can do in here, and we'll let that go. It should give us a menu of basically all the things that we can do. And, you know, again, the goal of this is to talk about job skills and things that people are actually asking for out there in the industry, right? We're working on finding things that are, you know, valuable to understand, to know how to do, right? That kind of stuff. So, all right, so we'll let this run. I think it's going to ask us for some other stuff. I'm surprised this box is taking this long to do anything. All right. Now it says that we've got these network interfaces. We'll just go ahead and leave that as the primary. It'll get the local. It's going to pull an automatic IPv4 as well. It might do IPv6 as well. That's fine. Our network can handle it. Let's see when this comes up, let's see what network it gave itself. We'll give it the host name Cali. We're going to call this, we'll go ahead and call it Cali 01 for now, right? Boom. Domain name, we don't need one for right now, so we'll skip that. And then give a new user, we'll call him Scott. And then, just name, yep. We got to give a password for him. Right, some short password for now, that's fine. And then it'll set up the passwords. We need to pick where our time zone is, and I'm in Arizona, so I'm going to pick Arizona. Fun fact, we don't change with the time like the rest of you guys do. Now it's going to go try to find those disks and see if it's going to automatically try to partition them, but let's see what it gives us as an option. We can typically manually partition our disk if we want, or we can use a guided disk with LVM. We can do encryption with Lux, typically, Luks. Let's go manual. Let's say we wanted to do this one manual. And it says, well, you've got all these things, and you've got this one virtual disk right here. And let's go say, are you sure that you want to wipe this disk? Or, you know, are you sure you want to do this? And I can go here. I should be able to select it and create a new partition. And I can give that partition a size if I wanted to. And I can do all this, right? And you might say, well, Scott, of your 53.7 gigs, where should they probably be applied? How should you apply those? And I would say, well, there's a couple of ways you can do it. Nowadays, since we really don't care about a server that much anymore, most of the servers themselves tend to be ephemeral. Honorable, you said you're eating a giant burger while watching this. Nice. Nice. Here's your options. You've got, I'm going to pull up, let's go find something real quick. Let's go here and then say CIS benchmarks. And here's my CIS benchmarks folder. And I go to, I think I got them in old outdated. And let's say that I had, do we see this general type here? Let's just say this is generally Debian, and Debian's pretty close to being Ubuntu. So we'll open this up with, we'll go ahead and go Chrome, because my Sumatra is set up differently. So I don't like using that tool for this. But here's our CIS benchmarks. And you might say, Scott, this seems like a lot of work at first. Yeah, the first time you build a server, if you want to do it right, there is a lot of work involved, right? You don't just willy-nilly throw a server together if you're going to use it in the enterprise, right? So you come down here and you say, okay, I want to figure out some of this partitioning stuff. Well, that partitioning starts at so it's 1.1.2. And we start to see that tempfs needs to be its own partition. I go, okay, so I got to give, tempfs /temp has to be its own. And I say, okay, I got to give temp its own. And then I got to give it some permissions. There's some things I have to do around no exec, no suid, and no guid, right? So I have to give those. And then we come down a little bit more and see there's the no exec. You can't have exec on the temp partition. And then dev shm has to be configured. So we got to make a size for this. And that tends to be a tempfs, so we could change that later if we needed to. But the point is, we have to do all of these things, and we have to carve them all up. So what I can do typically is I can go back, right, and I can say, you know what, that was a lot. Let's see if we can go back to where maybe we detected the disks, and let this thing detect the disks, and we'll go a different path, and we'll see, because it'll give us a chance when it's done carving it up. We'll go ahead and do guided partitioning for now. And we'll say, you know what, go ahead and set it up and go ahead and be encrypted with Lux for me so nobody else can get into this box later. There's our disk by default. And let's see what it tries to set it up as for us. So it says that, how do we want to do this? We can have one big partition where all 53 gigs, roughly 50 gigs, are in the same spot. We can have a separate home, or we could have separate home, var, and temp partitions, which are what are required for at a very minimum. There's actually a few other things we have to carve out, but that's the very minimum that we would need for CIS benchmarks. So I say, okay, we'll do that one, right? We'll say continue. And now it's going to come up and it's going to say, hey, you're going to change this. Are you sure you want to make this change? And then we're going to go, yep, it's going to change. And it's going to go and do that. Now, you don't have to worry. There's always this warning with these. And it's like, are you sure you're going to erase all the data? And you're like, well, the data on this disk, this 53 gig disk did not exist until we pressed the button to build this virtual machine. So, yeah, I'm pretty sure I want to do that, right? Right? Like, I mean, yes, go ahead and do that. So anyways, we're looking at actual job board requirements, and the first one was install, configure, and maintain Linux operating systems, right? Like, how do we do that? And in this case, we were just building out a Kali box to kind of mess around. You've got different package managers you can install in Ubuntu. You can install with apt, and you can update with apt, so you can put new things on there. Yeah, so we have these disks, yep, and we carve up the disks, and look, we're all the way up to partition XVDA5. So when you look at a partitioning of a disk, the XVDA or the SDA or the older HDA, those tell us what types of disks they are. Then this letter right here is actually a counting number. So this is the first disk. XVDB would be the second disk. And then we count through the partitions here, typically starting at 1, 2, 3, 4. And those would be, it doesn't have to be, but typically 1, 2, 3, 4 are your primary partitions, and then 4 gets given up to become the extended partition, and then that extended partition can be 1 through 63 more partitions, right? Yep. And so these are getting all formatted up and that kind of stuff. But this is the idea that we can install a system like this, but then typically we don't install things like this from then on. I'm going to leave this system right here real quick. I'm going to go over to Rocky 1 real quick. And I'm just going to reboot this node. I'm going to show you guys something about this node. People that haven't been here before. People that have been here have seen this. But this node this is a stateless image. All these boxes are stateless. Meaning if you reboot them, they come back up with no memory of this place. It's going to go down. It's going to come back up. It's going to re-pull the container image from Werewolf. And in that image, it's going to have a kernel and an init RAM FS. So that when the system boots up, Lord Processor, the name should be the same over on the Twitch side. It should just be het_Tanis on the Twitch side if you want to join from YouTube and hop over. You can also hop down in the Discord. You guys are welcome to hang out down there. But watch this box. It's going to do a thing called iPixie. And in an iPixie boot, he comes up with no knowledge of himself, uses the DHCP, which comes from the old BootP protocol. And the system finds the one DHCP server on the network, which is this guy right here, the .25 on port 9873. And it's going to give this guy the Rocky 1 version of the image. It's actually the container he wanted was Rocky Linux 9 Lab. That's the lab that I have built out for us. And then he takes the overlay files for this specific system. Okay? So, you know, we're looking at this and we're going through and we're just figuring out, like, you know, we were talking about there's been a lot of layoffs in tech and there's probably more coming according to the rumors. But how are these systems built? How do we go about the process of building and watching a server boot? And then if it boots improperly, some of you guys were watching these fail a few weeks back when I was first building them out. And we had to go in and figure out why the failures were happening. And we were using whatever tools we had, wherever we can get the logs from, where the process appeared to be working and where it appeared to be breaking, right? That's all part of the install, configure, and maintain servers. This is engineering level stuff right here. When you have to build new servers and then make them part of a template that's going to come into like a CI/CD pipeline and be built over and over again for the X number of years that the life cycle of that server exists, you need to, you know, really spend some time and understand how we do this, right? Down here, there's some security measures that they talk about, and there's the CIS benchmarks and the STIG standards, which are all very important for how we harden our systems, right? And sometimes you guys have seen, I'll pull up the STIG standards. This is going to be bright, but this is the STIG standard for some server. Let's say I wanted to look at, these are Rocky 9 boxes, so I want to go ahead and make a checklist from here, and then I could go through and I could look at all of the, let's say I just wanted those /temp ones. Remember I said temp is going to have to be on its own. So if the separate entry for temp is not found, this is a finding. So that means that the system would not have been correctly set up. And then we set up our finding details. This is part of how we report out to like our ISSO or ISSM, which is our Information System Security Officer, our Information System Security Manager. And we go and we report out all, however many there are. I think there's, remove all filters, 462 of these to make this system as secure as we want it to be, right? So anyways, that box is up now, and we had no problems with it. Let's come back over to our little stream build Cali. Stream build Cali's still doing stuff. Let's come over here and keep working while that's going. And it says monitor system performance and troubleshoot issues related to server hardware, operating systems, and software. So I added here these four. These are what we call the big four in the high performance compute world. But as operators of Linux systems and maintainers of Linux systems, these four will always be kind of your bread and butter. So for CPU, you have to know the number of processors you have, and you need to know how under load your system is at any given time. And those are the two easiest ways to do that, right? Then you come over here and you go, okay, well, what if we wanted to know like how much of the processors being used? I don't think we have sysstat on the system by default, but I can do like mpstat. Yeah, I don't think we have it. And then we'd have to do apt install sysstat to run that. But suffice it to say, you need to understand how many processors are in a box and how under load they are. You also have top. Top will kind of help you out with that a little bit because it'll give you the load average, and then it'll tell you how much of the CPU percentage is being used. And we could call this system pretty light load, pretty low on the overall system usage. We hit Q to get out of that. And then memory, you know, how much memory do we have in a system? Free-M will tell us that this is a 2 gig box. So that's in megs, right? So 2 gig box. We're using about half of it. And then a whole bunch of it sitting over in the buffer. So we're doing all right on memory. We can do, if we do an apt install -y sysstat. Let's just get sysstat real quick to show you guys some stuff. We've got a bunch of administration tools in there that will help us to look at how much memory is being used on a box, right? And I've got a different talk that we do where we go through each of these like in depth. But if you're just looking at a job board and they're talking about monitoring system performance and troubleshooting issues related to hardware, operating system, and software, these are the big things that we need to understand from for sure, how the system's working, right? So let's go memory. So we got vmstat, and then we do maybe 1, and then now we can watch the system, right? All right, so we've got that. And then we come down and there's disk information. So we can do fdisk-l and maybe grep for, in this case, like, what are these disks? SD? We can just do fdisk-l. Let's see what disks we have in here. Oh, they're VD. So grep-i for VD. And then now we'll get all the virtual disks on there. Lemnine, you said, what are the real world threat vectors that don't originate from the web network? Why isn't it sufficient to just lock down the ports? Unless there's a bug in your service which allows the user to run arbitrary code. Why does anything else matter? Well, Lamine, the number one thing to do is to lock down traffic that shouldn't be coming into a network. That's typically port-based and source-based, right? And then the next thing is to lock down what can get to your systems, which are service-based and port-based. Then at that point, but that's and then what we do aside from that is we throw everything into what's called a SIEM. Yeah, a SIEM is our SIEM. Yeah, so we're not going to go off into this too much, but for some of you that have not been around for it, we have talks on like compute and data security, where I go over, you know, what is defense in depth and how do we protect systems in the cloud and all that kind of stuff. Yeah, yeah. Okay. But we're not doing that right now. So I'll just leave that open. But then there's disks, and then so you can look at the disks that are there, but then you can also do ls block and list the block devices, and you can do block ID and see what's on the different block devices. And you just got a good kind of view of like what's going on in the system, and then from there you start to look at mount, and then maybe you just look at mount by itself. And this is going to give us way too much stuff because they have all this other crap on here. But maybe you're like, I want to see the mounted stuff, but I want to see it without all this container stuff. So we mount grep-v container, and then maybe we do a grep-v for cube, right? And we just get all that crap out of there. Man, where's all this other crap coming from? What is this? Hold on, I want to get all this other stuff out of here that doesn't matter. I kind of want to use, let's see, I guess snap. And by the way, I can do this in one. I can do this in one command if I want to, like this. It can be contain, and then it can be cube, snap, right? And then C group. That's the other one that's bugging me. C group, right? These are all things I don't actually care about. What's another one? Is there any other ones? That's probably fine. There's more, but yeah, this is all Kubernetes bloat right here. This is like a lot of extra stuff, because at the end of the day, really we care about just a few of these that are mounted on actual block devices. And I could have used VD or VDA and carved this down pretty good, but that's fine. So I need to understand my disks, and then with my disks, I can use iostat-d to just see block devices. And then I can use like iostat dash, what is it, XC, I think. Is it XC? Yeah. No, that's not right. It's XZ. So I'm going to use iostat XZ1. And then now I can just watch the system to see how utilized it is. How much disk IO is going in to my system, right? And you might look at this and go, well, what's a high load and what's not a high load? Well, that's going to be dependent on what historical data kind of looks like. And this isn't always the best way to look at it. I've shown you guys before, like in my home lab, right? So in my home lab, this is kind of how I like to look at historical data. This is the last 7 days on my system. This shows how many users are logged in, because we have people that access our systems for the Prolog labs. We've got all of our different CPUs over here, and how much CPU is on some of our different systems that we care about, and then memory usage, like how much memory are we using. All right. So anyway, so we hit Control C over here, and then now the last one is network. So we can look at our network a bunch of ways. We can do a bunch of commands we were doing the other day. IP adder will show us what networks we have. IPR or IP route will show us how the system is going to route out of those. You want the network to be the bottleneck. You don't really ever want anything to be the bottleneck if you can, Lemnine, but whatever you do with a bottleneck, typically you try to quantify what's actually slowing you down, and I use the use methodology for that, which is utilization, saturation, and errors, and I find out what's actually slowing me down. I figure out how to either bypass it or to parallelize things or do whatever I can to make my system operate faster, right? There is one type of thing that I do pretty often where the network does become the bottleneck, and that is in high-speed storage systems. I do a lot with Lustre and GPFS. Actually, I'm doing a new file system that's been released by Dell called Weka, W-E-K-A, and that one's really interesting. It's a really interesting file system, but it's they're highly parallel, very fast file systems. But you know, at the end of the day, you want to use as much of your resources as you can without slowing things down. All right. And Frank over on the YouTube side. Sorry, I'm missing some of your messages. Yeah, we're looking at just these are actual job boards. Like these are all like job board things that I've pulled or seen people post that they want to understand better. So I'm just literally going through them right now. And we got down into looking at some of the network stuff, and then we actually have a SAR dash what's the SAR command? Is it dash E and then TCP? Is that right? No. It's T. Oh, dash N. Yeah, that's my bad. SAR dash N, and then I can look at like TCP and error TCP, right? And what error TCP? Ah, oh, apparently we're not running any kind of SAR logging. But the point is, typically you can go and pull data out of there if you're running all of that, right? And X Shunyum, how's it going? Yeah, we're just hanging out right now. We're talking through some stuff. I've pulled up a bunch of job board things, and we're just kind of talking through what some of that looks like. All right. So, anyways, we get down here, and the next thing they kind of want. Oh, there's so much more on networking, but we'll get into that in the 16-week course as we go. But they want us to be able to implement and maintain security measures to protect our Linux systems from unauthorized access, malware, and other security threats. All right. So, the two main things we're doing on the system side there. TR hacks. Yeah, can I put this on the job board on Discord so we can practice? Yeah. Oh, all these commands and stuff. Yeah, I actually have this up in the Discord on the where do I have it in Discord? I think I have this down in presentations. I have an older version of this, but it's up there. Hold on. Yeah, it's hard to find stuff. I know, guys. There's so much crap on Discord in general. Maybe I put in projects. It's up here somewhere. I just so people have it because I know some people want. Nope, it's not in there. All right, I will put it up there. TR hacks, but I need to finish it and make it a little better before I do that. But then, yeah, I could put that on the job board discussion. Absolutely. Do you just want like some of it now so you have it? I give you. Yeah, I guess I could do that. Yeah, give me a second here. Yep, there we go. All right, Control C. I think it'll turn it into a file. From. I think it'll turn it into a file, but there you go. All right, so it's on there. Yeah, there you guys go. So you have them, but you're gonna have to fill out like I have not filled out all these other ones yet. I've only done this top one, and now we're on 3, which is. This is from a real job posting that I really pulled off of DICE a few months back. Implement and maintain security measures to protect Linux systems from unauthorized access. Okay, so how do we harden a Linux system? And I have that in one of my drawings. Let me grab, where do I have that drawing? Hold on, file, open, file from, I think it's in here, and I think it was called, I think it was just a talk. I think it was just I just put a name on it for whatever day we were talking. So, was it this one? Hold on. Different one. That's not it. It's not that one, guys. It's definitely not that one. Although this is part of our talks as well. Where is that? Hold on a second here. It's I swear it was just a numbered, like I just put a number on it, like this. This is the Prolog lab. At one point, it's a dated one. I'm gonna try one more and then I'm done looking for it. It's not that. It's not that. Not those. Not any of those. Yeah, shoot, guys. I don't know what it is. I'm already on this one. Is that this one? Oh, yeah. Okay, so it's this one. So We were talking about a golden image one time, and one of the guys had asked me specifically, could I write out all the things that I do to harden a server, right? So golden image, you could also think of this as hardening a server, right? And when somebody asks me how I would harden a server, this is man, did I spell hardened wrong? You guys got to stop me. Hardened. Control S to save. Okay. So systems that we deploy all other systems from are golden images. We harden them to security standards that come from our GRC team or just from good prudence. And typically these are what we do. We change all default passwords. That's a PCI DSS standard. You have to do that if you're taking credit cards or processing that information on there. All default accounts are either disabled or removed if not used. And when we say disabled, this is what disabled means. So watch this. We cat etc pass WD. And if you said, Scott, can you tell me how many users in this file are disabled and how many are not? I can. Watch this real quick. I'm going to say, so user sbin no login is a disabled, you can't come in as that user. And you say, can you prove that? Bin false is the same way. Let's do this real quick. Let's say user add -m Scott, and then I'll su to Scott user, right? And I became that user, no problem. If I do an echo on $shell, whoops, s shell, I'm in the bin sh shell. Now, if I vi etc pass wd and shift G to the bottom, and I change the Scott user to any one of these, which is like bin false. I like sbin false personally, but bin false is fine. And now I try to become that user. I cannot become that user. I'm still my root user. Root can do anything you want in the system, but the root user can't become a user that doesn't have the permission to even open a shell. Does that make sense? There is no shell for that user, so you cannot become that user. So I'm going to show you a trick real quick. You cat your etc pass WD out, right? You could cat it or you could just awk it to start. But let's say awk. And now awk is looking at fields. And the field delimiter that we want for this file is a colon right here. So I'm going to say -F:. I want to use that field delimiter. And the field I want is the 7th field. Right? And now that is going to give me all of those. But then I'm going to sort them and unique -C to count them. That's how many users can log in. That's how many users... So we have 4 users that can log in on the system. What did I say? Yeah, user add is the only one I know of. I've never heard of add user. I don't know if that's even a real thing. Xshunyum. It might be a thing, but I don't know it as a thing. Okay, so then benchmarks. How are you going to benchmark your system? Are you going to use CIS? Are you going to use STIGs? Are you going to build them with the OpenSCAP workbench? There are so many things to go spend time with in benchmarks. But you might say, well, Scott, where do we draw the line? Where are we done hardening a system to a benchmark? And I would tell you the answer to that is found in one of 2 places. They are either you searching your soul. No, I'm just kidding. They're either found in what's called the security posture of your organization. And what I mean by that is if your organization doesn't have anything, do whatever you want. But if not, if there is, however, like a security standard and a GRC, which is your governance, risk, and compliance team, you're going to have to work with them in an iterative fashion to get through and get your benchmarks to the level you want them to, right? And you're going to spend as much time as you need to here to get it right because, again, all other systems will be deployed from your golden image. That's why we do that. All right, software. Update or patch software. And the STIG standard says every 2 weeks. And software is only there if it's needed. You do not put dumb crap on your machines because that's just another what we call attack vector or footprint or whatever, you know? And it's only turned on if it's needed. So if we come to this server here, wait, no, wrong box. That's my home box stuff. We come back to the server we're messing with here, and we do an ss-ntulp to look at all the ports that are on it, and I go, why the heck is this box that's sitting out in my DMZ running a whole bunch of Kubernetes stuff? If I'm not running Kubernetes actively on the server as part of what we do as a company, why would I build Kubernetes on there? That's stupid. It's literally insane. Why would you run anything on there? Why would you have, 50 extra pounds in the back of a race car? You want that race car to go as fast as it can. Yeah, it actually does. So you need to. So in the CIS and STIG standards, we talk about how privilege escalation works. Absolutely. If this is going to be bright for a second, if we come over here and we go to, so I'm looking at the standards for this, and we go to like sudo. Here's all the sudo. Well, these are all the sudo commands to check things, but these are a bunch of different. That's not great. Let's go with PAM. PAM is your pluggable authentication modules, and here's all the pluggable authentication module things that are affected by the STIG. You gotta, as people log in with SSH right here, you've got to use PAM inside of the configuration. And I've shown you guys how to scan these types of things on systems before, but this is one of the tools that we use to report and then go look at it. And if you've got a tool that will build you an XCCDF type file format, then you can get these checklists out of it, and you can just load your checklists in, so then you have all 462 checks, and then you only have a few that you have to go manually figure out. And that's way better than doing them all by hand, guys, because they suck doing them by hand. You want to have some kind of host intrusion detection system, so good logging systems on your system. Maybe you're going out to Loki, or you have syslog running. So if anybody logs into your systems, that's automatically sent back out of the thing. So if I go, so watch this in my home lab real quick. Let's go to, here, right? So we go here, and we go over here, and we check on, here's my prolog, and I'm going to go to logs and apps. And then on logs and apps, we're going to switch over here to, we'll leave it on secure, and we'll look for Rocky, right? So here's all our Rocky systems. And from this werewolf box, right here, I'm going to exit Rocky 4, and I'm going to jump back into Rocky 4. Then I'm going to exit Rocky 4. I'm going to jump into Rocky 4, but I'm going to try to jump into Rocky 4 as bad user, who I know does not exist on Rocky 4. I'm going to hit Control C, and it says, hold on, look, all these connections are attempting to happen from the system. So bad user Rocky 4 says connection closed by invalid user, bad user, invalid user. That's a user that doesn't exist on my system. And that's coming over to my logs in real time, because some of you guys saw that I built out in Rocky 4. We've got Promtail running, and Promtail is kicking over logs in real time to Loki, right? So as we talk about like good logging systems, a good logging system, you say, well, what's a good logging system? To you as a systems operator or a systems administrator, a good logging system is something that can send off the logs in real time, such that if there's an error on that server, or it is compromised and taken down for any reason, you can go check the logs before you bring the server back up. If at any time as a systems administrator or systems engineer, you are called to task and you try to go find the logs for a server, but you can't get those logs off the server until the server has been booted back up, there has been a failure in the process. I'm not calling you a failure. I'm not calling your company a failure. I'm saying there is a failure in a process. Either the process doesn't exist, that's an automatic failure. Or it's just not there, and or it didn't work because Loki wasn't running, or Promtail wasn't running, or syslog wasn't running, or whatever. That's also a failure. A disk filled up and something stopped logging, that's still a failure. I ask you guys sometimes, is it still a security incident if something happens on accident and exposes all your data to the web, or if it happens on purpose? And the answer is it doesn't matter. It doesn't matter why it happened. It's still a security incident. And I will tell you that any security engineer you've ever worked with will fight that one to the death, right? All right, so HIPS is your host intrusion prevention system. So you have your tripwires and your fail to ban, and there's some other ones in here that I didn't even include. But you have AID. AID is a tool that will keep file system in integrity. It's like tripwire. You've got fail to ban, which can block people out if you keep trying to connect into like my home lab. So if I go over here back to my little monitoring here, and I go to just failed, and this is the last 6 hours of people trying to log into my system from out in the world, and I hope these aren't people like looking at these IP addresses. I hope looking at these times were so fast that they were probably and they were timed pretty well. This was probably a system trying to log in. It probably wasn't a human doing that, but it could have been. But the point is, I hope this wasn't somebody in our Linux systems administration class, because now they've locked them out of that system forever. They're never going to be able to get back in from that IP, right? And what in the last 6 hours we've had, this is way smaller than normal, but it looks like we've only had maybe about 40 or so. That's probably about 40 total users trying to log in. But somebody tried to come in a bunch en route from some IP addresses here. Yeah. All right, so go to our golden image, and then host level firewalls, you should have those on. You can have host level firewalls on and still kind of protect your system. Hey, Ops to Dev, how's it going over on the Twitch side of things? YouTube side, hopefully I'm not missing anything. Looks like you guys are talking about some of the same stuff that we're talking about. All right. Connection should not happen by root into a system. So some of you guys know that I don't allow users into my systems. Ops to Dev, we are going through, these are real job postings and real job boards and actual requirements. The requirements are numbered here. And then what I responded underneath for you guys to go look at or study are what we're going through. So we are down right about here. We've been working through them as we go. And I've been showing you guys stuff, and then I've been pulling up some of our different documentation around. We should have a firewall. We should have the ports that are open should be only ports that are really needed. And then over here, we should have SSH and SSHD configs set up properly to block things off. Yeah, so Ops to Dev, the goal of this was the most asked thing I've had the last 2 weeks. The thing that people have asked me for in the Linux System Administration course the most was like how do we go find a job? Like what skills do we actually need? And yeah, we're working through all the things that I think we need to know how to do in our 16-week course. But this is just kind of us crashing and looking at what jobs are out there and what they're actually asking for. So, do we turn on FIPS? That's Federal Information Processing Standard. Do we turn on SE Linux? And then it's a more secure Linux, and it's labeling on top of the file system that causes additional security context as people try to log in, right? And as processes try to run and those kind of things. And we actually talked about it in the class this weekend for people that were around for that. They want you to know how to maintain systems. So here we use ss-ntulp to see all the ports on the system. Posture will be varied based on the server location. Is it internal? Is it in a DMZ? And Zero Trust will tell you it doesn't matter where a server is. But most of us in the actual implementation of things do care if it's an internal server or a DMZ. Internal servers, actually even in government processing, tend to have slightly more lax standards on what they do. You need to remove old or unused software. Look, if I go to this server, right, and I do a dpackage-l, and I grep out of all the packages on the system, I look for either bzip or gzip. And dpkg. That was my bad, guys. Sorry. And I see that both bzip and gzip are there. And I say, well, that's cool, but gzip supersedes bzip in every way, let's just say. It kind of does, but so I say, well, I really don't want old software here, and what the hell's this pigs? Let's just get rid of bzip and pigs. So I could go and I could remove that from my system because I don't want it there. I don't want, when I do a dpackage-l, and then I do a word count -l to just give me a general count, I've got 1,504, probably about a little less than that, freaking packages on the server. Why the hell do I have all these packages? It's probably Kubernetes and some other stuff. But the point is, if this was supposed to be like a lean system, like if this was a, when I build high performance compute type devices, I don't even want 50 packages on there. You guys might say, only 50? Yeah. SSH, NFS, GS, was it GSS API or whatever that is, so that NFS works properly. And there's not very many, guys. I keep it as lean as possible because, again, why would you build a drag racer car and then have a couple of 45-pound weights in the back of that thing? You might keep a couple of 45-pound weights in the back of your truck to like give it traction when you're burning out or something, maybe, but not in a drag racer where you actually care about every pound compared to the horsepower of that vehicle, right? Yeah, your boxes, yeah, control byte, that's perfect. The system should do exactly what you need, nothing more, nothing less. There's a way that's often attributed to Einstein with engineering that I really like. It's a quote that says, "Make things as simple as possible, but no simpler," and that's also true of all good engineering. Things should be as simple as they can be to run, but no more simple because then they don't run, and no more complex because then they're just adding bloat, right? So anyway, so there's that. Remove old stuff, and then audit your users. Who are your users on this system, right? We catted our Etsy pass WD, and we can see all the users that are there, but we can also go and figure out, well, how many total users are there? Right, I can word count like that. I see there's 48 total users in there. And then we have that command from earlier, which was our awk. And that thing can sort them and kind of tell me which ones are, which ones belong in, or how many of them are active. And then you might say, well, Scott, how would you find those then? Well, then I would just grep like this. I would just grep like bin bash from Etsy pass WD, and I'd get those 4 if I wanted to see the whole thing, right? So this is just for me to get a, this is like what I call my rough in. Like this is like roughing something in and just like building a frame. Like if you were a carpenter, this would be building my frame around what I want, and then I can go dig in on exactly what I want after. This is how we do things. Ravi, I have all kinds of Kubernetes stuff, yeah. But most of my Kubernetes stuff just tells you to go look at, other paid for resources, because there's some really good stuff out there from like Mumshad. Mumshad Manabeth, if you guys don't know who he is, that guy's stuff is probably some of the best stuff on the web for like your CKA type. All right, we audit our users. We use tooling to track the users. So fail to ban Loki Grafana. You guys saw this. This is Loki being implemented through a dashboard in Grafana, and I can see all the attempted logins to my system from everywhere. Yeah, Mumshad's stuff is really good. All right, so then we manage users' account permissions and file systems. Do I know how to do that, right? Do I know what, whoops, not here. Do I know anything about, so ID Scott, that's a user I made. All right, what do I know about Scott? His user ID is 1001. I can grep Scott, Etsy pass WD, and there's information on him, and also Etsy group. There's information on him, right? I can go and I can look in his home directory. I'm root. I can do whatever I want, right? I can see all of the files that are in there for him. He's got these basic little configuration files. We call these the dot files. And these files determine how his bash profile behaves when he starts up. How can we know when somebody was last logged into the system? Yeah, use last, and then I pipe it through more, and it'll show you all the logins according to what's called the wtemp log. Yeah, so you could do that. I would do last, and then like grep-i for Scott and see if Scott was in there, but he's not. Also, last is one of the few things. Let me show you guys something. This is annoying. Last is one of the few things that reads backwards in Linux. So in my home lab, if I go here and then I type in last, all the stuff down here is from January 30th. We've been logging in the system a lot. So a bunch of you have been logging in even up till today. a bunch of you were logging in as streamer, right? So there's all you streamer guys, and you guys have been logging in, but this is backwards. And I say, well, there's a little tool that's really useful for text reversing. It's called tack. So you cat a file out to see it in order, but you tack something to flip the text around. So now I'm reading it in the order I want to, which is the most recent on the bottom, all the way up to the oldest on the top. Because it is kind of annoying that that last by itself it's kind of in a bullshit order. I don't care. I mean, look, I care a little bit about what happened back in January 30th, but this was me messing around on my system from AWX, doing a bunch of stuff and that. So last tack will flip it around, and now here's all the most recent data points of people coming into my system, right? So anyways, there's that. Check permissions on directories, check group management. So if I want to check permissions on his home directory, ls-ld on home Scott, and I can make sure that he's got the right permissions. I don't like those permissions, so I might chmod -R 7, let's say 750 on home Scott, and now the Scott user and people in the Scott group are the only ones that have the ability to reverse into home Scott, because other users should not be able to get into my home directory as the Scott user. I don't want people walking in, and even though they couldn't write anything in there or change anything, I don't care. I don't want them in my home directory. So that's actually a STIG setting where you don't allow more than 750 in a home directory. But I tell you, most systems that I secure, I do no more than 700 in a home directory. Oh yeah, Scott right here. This is the Scott user, and he's the owner of the file, and this is his permissions of read, write, execute. All of these should be 0, so that would be 700 like this. This is how I secure like root systems and stuff, like this. And then now, nobody else, even in my group, has permission, and nobody else even in my, well, everybody else in the world, which is nowhere. But yeah, okay. But we did some of this weekend. We're going to do more of it as we go. We're not going to focus on any one thing right now. We're just talking about job things, like what are people looking for in the job, you know, getting you guys experience and being able to put stuff on your resume and stuff. All right, this one, they wanted you to be able to perform routine backup and disaster recovery procedures on your servers. So they wanted you to have a knowledge of how we do these things. And a lot of times there are these rules out there. There's things to study to be able to talk about this intelligently. But some people call this I think it's called the 3-2-2-1 rule. And I might be wrong on it. Some people call it the 3-2-1 rule. So there's different ways that this works. But in this case, it's 3 copies of the data. 1 is prod and 2 are backup. Then on 2 different types of media, and 1 of them is offsite. Just saying data offsite is not a DR solution. It's not a full business continuity plan. So we're not going to get into what the difference between a disaster recovery solution and a business continuity plan are. But let me just emphasize to start, a business continuity plan focuses on the business operation things that are required for your business to be back making money. That's what business continuity plan. Disaster recovery deals with the whole idea of getting our systems back running. So you might say, well, which one is more important? Well, this is where your company makes money, so this informs this. So the business continuity plan informs how you build your disaster recovery solution. Because I'm telling you right now, if I have 10 engineers underneath me and they're all trying to get the systems back up, but the systems they're trying to get back up are like Okta, so that our help desk, or not even our help desk, our human resources can get in and check what resumes have been turned in over the weekend. That is not nearly as important as getting the production website that we sell $1 billion a year in revenue on. Yeah. So you guys can go look that up. Go look up whatever the rule is. I thought it was 3-2-2-1, but people have different rules, and you can go read what they are. Some people call them 3-2-1-1-0. Man, guys, I've seen this a billion different ways, but the general gist of it is 3 copies of data, 1 prod, 2 backup, and then 1 is always off-site. And why is it off-site? Because data being off-site, there's two things that happen. Some of you guys have been here for my ransomware talk, but I'm going to show it to you real quick. And then, again, you guys can ask me if you ever want to go over any of these. Not DevOps Pro. Where's our Solutions Architect Pro? So I've got to talk about ransomware protection using AWS. This is an old talk that I gave a while back. Let's get this out of the way. And one of the things I want to point out as we talk about this, don't worry about all that crap, don't worry about all that. This right here. What does ransomware do to a company? It does two things. There are two things ransomware is doing. It encrypts the old data and it moves some stuff forward. I know this is a big talk, but ransomware does two things. They try to take your data first, and then they try to change your data so it's unusable for you, right? And the thing about that is, if you have an offsite solution, meaning no process can touch the data, you can bring that back, right? You can bring that back, and that saves the second problem, which is the problem of you not having access to your data. Now, the first problem, which is whether or not they got access to your data when they first got control of something, is corrected by having data encrypted at rest. So data encrypted at rest and an offsite backup will ensure that you don't have the two major problems of ransomware. Will you still take an outage? Possibly. If you get hit with ransomware, you may still take an outage during the recovery, but you don't have your data compromised on the C, and you don't have your data compromised on the I of the confidentiality, integrity, availability model. You only get a little bit of compromise on the A, and that kind of stuff people typically forgive you for. If you lose everybody's social security number and all of their personally identifiable information, well, that loses that loses you a lot of customers, right? So that's not as good. Also, remember, when you're in these labs, you only have the lab for an hour, so the lab will be deleted. And then, by the way, this is very important. Until you've tested data recovery, you do not have a backup solution. If you've just thrown data into a black hole, and that black hole says, yeah, I got the data, I'm good. It looks like Mayhem in that Mayhem commercial, if you remember that, where he's just sitting there telling the lady you're good. He's her blind spot, and then he causes her to like spin around on the road, and he's just laughing. Yeah, Exunium. Yeah, in the U.S. we have HIPAA and some other things that govern how we deal with the accessibility of insurance data, right? Insurance and medical type data, right? So here's that. You can use agents or tools for backup. Avmar, Bacula. I'm a big fan of Bacula. You can use cloud with AWS agents, and then you can just move data into like a file system. You can use scripts. You can use rsync, SCP. There's all kinds of ways to do this. I wouldn't white knuckle it with scripts so much nowadays because there are really good agents out there, but then you tend to pay a little bit of money, right? So there's trade-offs. Do we write stuff? There's always the build versus buy trade-off in an organization, right? And if your organization does not specialize in building software, you might not want to just have your Linux engineers out there just one-offing scripts to build stuff. That's not a great way. That's not a great use of their time, one, and that's not a great way to figure out or to go forward. You know, you're just gonna be wasting time on stuff that's not being maintained, and then it's just not great. All right, so anyways, let's restart this. I'm gonna restart this scenario, and the next little thing from this actual job posting we're in is you need to know how to install and configure server hardware and peripherals. Well, if I have access to the server, I can obviously go power the server down, open up the rack, pull out the guts and the internals, and add a PCI slot or a PCI card. Sure, I can do any of those things. But can I look at, once the system comes back up, how do I know that that piece of hardware that I put in there actually came up properly? Well, your system, when you first boot an operating system, when you first boot any device, your device does what's called a power on self-test, right? Power on self-test goes and walks all of the system, checks for connections that are bad or things that aren't working. Some motherboards just beep if they fail. Some motherboards will give you like a number code on them. That's kind of an older thing that doesn't really happen as much anymore. But some motherboards will write to like a diagnostic center, and then you can come in through like an out-of-band or a console channel and pull the information off, right? But for now, let's just say that everything came up and I got to a running kernel, well, I can do a dmessage and then grep that through, or I'll pipe that through more, and I can go look at from the time my kernel first got called, how did it do what's called walking the system bus? Power on self-tests and walking the system bus are very similar. Here's the kernel being called for the first time, and then now it's going to start walking through the CPUs. It's going to start checking all of its RAM. It's going to start seeing what's going on inside of the system, what kind of CPU information it has. And then it's going to start coming down. We're just going to skip a lot of this. It's looking for specific kernel calls here, and are certain things turned on, right? But we don't care too much about those right now. And then we come down here, it gives some more information and maybe things that we're turning on. You know, we see one CPU. It's good to know. You would expect more. Well, you would expect it there. We get down here and we start to see the PCI bus. And it does what's called walking the PCI bus, right? And it goes and it checks for all the things that we would expect to be there. It loads up drivers for those things. It plugs in modules if modules are required. All these things, right? Here's more PCI. This is all PCI stuff. So where I'm going with that is you can go that route, or you can do something called LSPCI, and you can just see all the things that are plugged into the PCI on the board. All the things that this thinks that it can use. Now, this is a virtualized machine, so it has a bunch of fake, just virtualized things. But those could be usable PCI addresses if those things were added through the system. All right, so there's like all this stuff that's on there. You can do LS USB. We don't expect any USBs on our system, but if they were, we could list them. And then we can go look for kernel modules. We can use LSMod and go, let's just do like a word count -L. That's going to be 105 modules, so maybe I'll pipe it through more. So then I can look at all the modules. And then maybe I say, well, I knew it was something. I don't know exactly what I was looking for. I knew it was something like IP, and grep-I for IP. That's fine. And then now here's all of the IP type modules that are loaded up in the system. And then I say, oh yeah, that's it. It was IP tables. I want to know if IP tables was available in the system. Is the module loaded for the kernel to use IP tables in the system? And is it capable of doing IPv6 tables? Yes. Yes. I could then say, if somebody asked, is the kernel ready to filter on those? Yes, it could, right? If those weren't there, it's not ready to. At least not with your IP tables. The newer ones in Rocky nowadays are NF tables. Let's go look at that real quick. Let's go here. I'll clear this up and then do, what is it? It's dmessage, sorry, LSMod, grep-I for IP maybe. Yeah, we don't have any IP table stuff in there. Let's just look for tables. Nope. What is in here? There's all kinds of things. But there's nothing going on in here about IP tables, right? Not much going on in this box anyways. This box is pretty lean. I like that. All right. So, you know, you got your kernel mod. You can go see about how the system's up and what's working and what modules have been loaded and drivers and all those kind of things by looking at these different pieces of equipment. All right. Then the next thing they want you to know how to do, they want you to know how to collaborate with other IT professionals and plan and implement system upgrades and migrations. Well, you can go in, right? You can go into an interview and just say, well, I assure you strongly that I do work well with others. And they'd go, well, that's okay. But what's better, that I think probably will get you in the door more, is to go study ITIL. Maybe even go take an ITIL v4 test. I passed an ITIL v3. It was pretty simple. There's a TOGAF. That's the open group for architecture frameworks. You can study Agile, and at least, look, I understand that people are like, we don't like Agile. But when you look at why most people dislike Agile, it's almost always because where they were using it, it wasn't doing the actual Agile things. There's only 4 things that are actually supposed to happen in Agile. Most other things that you've probably used within Agile actually have to do with other frameworks like Kanban or a waterfall framework or something. But Agile itself has an Agile manifesto that really only deals with 4 things. Does anybody want to see those 4 things? Lord Processor, I put all of this stuff up on the Discord, but unfortunately the commands I'm doing are gonna probably go away. Yeah, so here's, hold on. I keep opening up my thing. I probably should just leave it open. What is that called? Hold on, that's in our, I think it's in our soft Linux skills, soft engineering skills. Hold on. What were we talking about? Which one? Hold on. Oh, Agile, hold on. Is it here or is it in the other one? Give me a second here. All right, so here, yeah, here's the basic stand-up meetings. Is a talk about like soft engineering skills, things that they don't necessarily teach in college. Although it's funny, because I teach the same thing to my college students, it is taught in college. So then I can't technically say this isn't taught in college because I actually do teach this to my college students. So it creates what we call a paradox, right? Anyways, here's the 4 points. This is the basis of Agile. Individuals and interactions over processes and tools. Working software over comprehensive documentation. Customer collaboration over contract negotiation. And responding to change over following a plan. Those are the 4 things that you're supposed to do. And most everybody that I've ever heard complain about Agile points to, well, we were just following the plan and we never responded to change. And I'm like, well, then you weren't being Agile. And they're like, well, yeah, but that's what the project managers want to do. And I said, well, I always tell people, I'm like, well, you got to call people out. When they're not doing stuff, you got to, you can't just call something Agile and then not do Agile shit. That's not how this works. All right, anyways. All right. I'm getting myself worked up. But we come over here. If you can, show how you've done this in the past. Talk about your deadlines and your planning. And how did you work back from a deadline based on what we call a critical path to ensure that something got delivered at the correct time, right? If you really need to, you go take a PMP and you study for the PMBOK, or you study the PMBOK, which is the Project Management Body of Knowledge. And the PMP certification is kind of this high level, I understand how to do project management. And it's funny, I almost took a PMP back in 2008. I was going to take one, but I'm like, nah, I'm going to stick with engineering. So I actually never took that. But I could take a PMP. I think I could probably still walk on and do all right on that. I don't know if I'd pass it right now, but I definitely at one point would have walked on and taken that and passed it, I think. Well, I'm pretty confident with the guys I know that have PMPs. But anyways, I digress. I studied quite a bit in my first master's program for that. So, all right. Anyways, systems configuration, procedure, and troubleshooting steps. And then I ask, how do you take notes? Keep everything in a raw format. I've shown you guys this. Like, pull things out and have kind of like a raw format, and then clean it up for the final consumption. Right? Let's go back to edit and redo. Okay, there we go. Clean it up for the final consumption. Why is that? That's super weird. What is going on with that thing? That was one of the weirdest errors I think I've ever seen in Notepad++. All right. Then it says provide technical support and assistance to end users and other IT staff. So that's been a big part of what we've been talking about. You got to be able to respond to tickets and respond to what end users are going to need. Users are going to send you ridiculous requests. This is going to happen. And if you want to kind of expose yourself to a little bit of those requests, let me go show you Fisherman Guy Bro, one of the guys in our little community here. He put together some little junior sysadmin things. So if you're a new sysadmin and you want to go through some of his things, I'm not going to do them all right now. We've done them before in the past. But if you want to go through and kind of see what life is like as a sysadmin, getting tickets in, this will show you kind of what the life is like. Right? There's some pretty good info in here, some good things to practice. He also shows you how to run a little local LLM, and you could hit a API for your if you want to run your own little large language model and ask it questions and stuff. So that's the kind of things he shows how to do. He also streams. You guys can go hang out on his stream. We're trying to get him to stream more, so that's why I mention it all the time. But anyways, these are the things you never write. You never write these in the tickets, but you can think them all you want. But picnic problems are problems in chair, not in computer. Pebcac is problem exists between chair and keyboard. Layer 8 problem is pretty funny. I heard this one the last time I talked about this. Somebody mentioned the layer 8 problem. That had me chuckling. And then you got to document and train users on how to access your systems. So what does that kind of look like? So like in my home lab, we have a way for you guys that are part of the professional Linux users group that are doing the Linux systems administration course to come in and connect to our system, right? And that looks like this right here. We've got this syllabus. Oh, I already had the syllabus open. And in the syllabus, I have this. This is my simple little attempt to show you guys how you get into the system. You come in off the internet, you hit streamer1 at prolog.asus.com. On 22, you'll automatically hit that. And then that jumps you in. You've got to know the password, and you'll get into the jailed streamer account. And then from there, you can jump into any of the 19 Rocky boxes. And then you get home opt, and actually Labs is there now as an NFS share. And you can do pretty much whatever you want in those boxes, and then you reboot them when you're done. So some of you guys have gotten in here and done that kind of stuff. I advise other people not to try to get in here because you'll lock your IP address out forever, and I'm not going to be unlocking them during this. So don't get yourself locked out. If you want to access the systems, do it the right way and go find the password. Password's in the Discord. It changes every week. Okay. Stay current with industry trends and best practices related to Linux. They actually ask you to do this. This is one of the things they say to do. Maybe my number one thing about this would be maybe the best free thing on the internet that I know of is just go on Killer Coda and practice. There are free labs galore out there. You can get more skills in all these different things. You don't have to do my labs. You can go do anybody else's labs. I don't care. I care a little bit, but I would prefer if you guys at least had, come in here and do these sysadmin labs until you feel confident taking a ticket, because you're going to do ticketing. You're going to get tickets from users. They are going to be ridiculous. They're going to ask you for things that do not make sense because they are not the ones that know how the system works. You are. And you're going to have to sometimes squeeze out of their ticket what they want. Sometimes that means calling them up. Sometimes that means sending an email, depending on the urgency of the request. And there may be some triage that you have to do, right? So you can get certs. You can get certs. There's hands-on Linux certs that exist out there. There's hands-on certs. Maybe you don't want to be a Linux systems administrator, so you go get some Kubernetes stuff, and you learn how to build out and practice Kubernetes. You can attend conferences and watch other people do stuff. But I don't think any of this stuff is as good as getting your hands on, not for you and not for your confidence, right? Maybe some people are really good at just listening to other people and they learn everything, sure. But if you said right now, if you were like, Scott, is it better to stay here and listen to you, or is it better to just shut this off right now and go do Killer Coda? I would tell you if you really want to better yourself, shut this down and go on Killer Coda right now and just do that for the next couple hours. That is better than hanging out and watching me stream. Better than watching those guys in the morning that are just going to be all amped up and doing whatever stuff those other infotainer type streamers do, that aren't actually trying to teach you anything. That they're fine to go hang out with. I like hanging out with some of them, but I realize that they're not teaching me anything. I'm not getting any better there. And you're not for most of them, right? So attend a conference, join a professional group. If it's not our group, that's fine. Find somebody that's out there. Yeah, Cuddlingus, if that was it, I would tell you to go. But you can hang out too. And some people can do the labs while they listen. But the point is, I would literally go and spend my time here. By the way, it might surprise some of you to hear this, but when I first got into tech, I realized I was always going to have to be in a classroom. I realized this very early on. This is why I'm a college professor. So when I do this and you guys see me typing commands all the time, you guys realize I'm also remembering those commands and drilling them into my own head, even though I live in this space. This is what I do all day. I do Linux literally all day. And some of you guys probably maybe don't believe that or don't understand that, but that's all I do all day is command line Linux. This is what I get paid for. That's it. Except for college. In college, I get paid to yell at my students, but and then look, find a mentor and learn Linux from them. Find somebody out there that you can stomach for more than 10 minutes and ask them Linux questions. If they're busy, like I'm a pretty busy guy, ask them down in the Discord. And then, people will answer them when they can. We'll try to answer. We try to answer questions down in the Discord. I try to help out with a lot of that stuff if I can. All right. So this is another one. This is a Linux Systems Administrator one that somebody found. I took this literally right off a post. First one was, is that the same thing again? I think this is the same one as up here. Looks pretty similar. Yeah, it's a little different. So what do? We install, configure, and maintain computer systems, servers, networks, and peripheral devices. Oh, let's go back to we got to install running over here, don't we? Oh. You need to choose one for our virtual disks. So let's take an encryption phrase. Passphrases are recommended to have a length of 20 or more characters. Oh, man, I'm never going to remember that. Let's go with, what's a good 20 length character passphrase? Let's do this. See if that works. Now it's going to make those disks. It's going to put that on there. I used a silly little passphrase called I just made it up. The show must go on, right? Now it's going to go and it's going to partition those disks. I added some seed numbers to it though. But now it's going to partition those disks up for us. And then hopefully after this is done. So we didn't even get past this stuff. That sucks. I thought we were at least on the install. All right, so now so we've got slash, which is root. We've got swap, which we don't really need. Temp var, and then we've got boot, and then we've got some crypt going with Lux. So that's pretty good. Let's go ahead and let that partition the disks up. We'll come back on that later. Yep, we're gonna write to the disk. Yes. Continue. All right, that was our build from earlier for some of you that came in later. All right, so we install and maintain computers, systems, servers, networks, and peripheral devices. This is our bread and butter stuff. We need to know how to install systems. We should know how to compare a working system to a busted system to see what's different. So if we have two servers and one of them stops doing the things that we expect it to, we need to be able to get in there and figure that out. Okay. This one says administer and troubleshoot environment systems, application software systems, Active Directory, and DNS, and Exchange environments. So let's say we were back over here. Killer Coda, I'm just down in their playgrounds, just doing their generic environment. So I have two machines. And how do I troubleshoot? Let's look at some of this stuff. How do I troubleshoot the operating system? Well, let's say, what's the operating system doing, right? Let's say the operating system is no longer allowing users to log in. Well, if I was on the system and users were not able to log in anymore, I would start to look at how users log in. And the service that users log in on tends to be SSH. So the SSH is the SSHD daemon. So it's right here. So we can do a ps-ef grep-i for SSH. And now we see that here is the SSH daemon, right? And we see that it was started. We see that it's got this process ID of 735, and its parent process ID over here is 1. Now, if you haven't been in Linux systems long, then you don't know what the significance of being number 1 is. But have you ever given your dad a number 1 dad mug or something like that? Number 1 is system D, and system D is starting all the other processes. So I should then be able to say, well, if that started as 1, I should be able to do system CTL just like this, and this will list everything. And I want to search for just SSH. And there's our SSH service. So now I do a system CTL status on SSH, and I'm looking to see the 735 process ID. I should see 735 as my process ID. Yep, there we go. And I see that the system is up and running and it's doing the things that it should do. And that doesn't track with users not being able to log in. So if I see the software open and I see that it's running and I see that it started, then I start to look, are there errors in logs? Are users not able to get in? Like I will try to log in as a user while I do a tail-f on var log. In this case, it's auth.log. This is where their logs go. And I will try to log in as a user. And as I try to log in as a user, I'll see what kind of errors pop up here, right? And if you need to see that, we can go to tab 2 over here like this. And we can SSH to like node 01 real quick and do a tail-f on var log auth.log, right? And then I'll just hit enter a few times so we've got a blank page. I'll come back over here and I'll say SSH to node 01. And now when I do that, I get over here that I accepted the public key for root. Okay, good, good. And then I come back over here and I exit because the root user was able to get in and out of there with no problem. But why wasn't a user able to get in? And then now I have a data point. I know that SSH is running here. I know that it's accepting connections from root, but the users are not able to get in. So now I might have to go and dig into do we have a third-party authentication happening and now that's not happening anymore? Is that through Kerberos? Is it through SSSD? I have all these kinds of questions, right? But I have proven to myself that node 01 is still accepting SSH connections, right? If that were what I was trying to prove to myself at that particular second. And I think I've told you guys this, but my troubleshooting process is 100% of the time I am trying to figure out what I know and what I have assumed and what is wrong about what I've assumed. And I keep putting things down into a bucket of, I know this works, I know that works. Why doesn't this next thing work? And I'm asking questions as I go, and I'm not doing it anywhere near as fast or as well as as Sherlock is doing it, but I'm doing the same type of deductive reasoning that he would do to get to an end-type state, right? So, troubleshoot these things. So the system is up, it's running, it's doing that. If I need to see how SSH was started, I can type in cat there, and systemctl cat will go and cat out the file. So libsystemdsystem ssh.service. If it's down in libsystemdsystem, that means that the system controls it. And if I go make changes to this, I can expect this to get overwritten with an update. However, if I were to have taken the service out of there and I were to cd to etc systemd system, and in here, the things that are in here do not get updated. So if I just go make a new service in here, the things that I put in here do not get updated automatically by the system. And there's a whole bunch of different places that are like that. And typically I don't keep them in my head. I go look them up if I need to, if something's behaving differently than I expect. But in here, you might notice that there's an sshd.service. But if we look at it real quick, it's just a soft link to that other one, which is the one that's actually being maintained and actually being called on the system, right? So that's what a soft link looks like, or a we call them soft links. Some people call them they're sim links, right? All right. So we are just going through and answering questions about trying to get better, or trying to, like, this is a job that somebody really wants us to be able to do. This is actually something somebody took off the internet right here. We need to be able to monitor the system performance to ensure network resource availability. So, over here, we are looking at, this is that same kind of concept from earlier. The network resource is still a finite resource. We have what the heck's the name of that tool? Let me see. Do we have SAR on here? I think that one's still not running. Oh, apt-y install syststat. Yep, and then we'll start SAR as well. And to check how we start it, I always forget how to start because I'm not sure exactly what SAR is called. Systemctl, grep-i for SAR. It'll tell. There's no SAR, huh? I thought there was a tool for starting SAR. We can do Shift G to go to the end, and this may just be running now. Let's go check. I'm not sure exactly how Ubuntu does it. Let's go SAR-N TCP and ETCP. Oh, it's sysstat. All right. Nope, we're gonna start it. Running. Now we should go be able to. No? I don't see. Typically we have a SA log in here. Let's look at our error again. Oh. So sysstat services started. Be running. Let's just run a SAR-R real quick. Huh. Typically you can just run SAR and see the data. Alright, whatever. We'll just touch that file. Screw it. Just touch the file. That's interesting. I guess I've never seen that before. And we have a lab that does SAR, so I'm surprised that that's not started. Now I kind of want to go look at the lab. Well, I got a lab that makes us do SAR. Give me a second real quick. Because I'm not sure why that's not coming up right. So then the Linux lab. I want to say it's the very first one. We're going to go through this a little bit fast, but if you guys have never been in one of our labs, here you go. New system admin, you're trying to figure stuff out, and we're going and we're looking at the system, and after we do all those things, we move on. We do all that. All those things work, and then now we dig a little deeper into networking, and yeah, SAR's working just fine on this. So, oh man, I think I know what I was doing wrong. Hold on. Because when you do it without the numbers, oh geez, well that's dumb. So you guys see what my problem was I wasn't telling it to do it at an interval and a number of times. Oh well, that'll be my dunce cap for the day. Monitor system performance to ensure network resource availability. So in my lab, I look at resources like that through my security connectivity. And what this is this is my main jump box right here. And my main jump box wants to reach out to DNS and verify from 3 different DNS vendors that exist out there. Do I have a good query of DNS? and it uses I can tell you what they are if you guys want to see them. Here's what it uses. It uses 1.1.1.1, which is I forget who that is. It uses 208.67.222.222, which I think is Open VPN, and then it uses not Open VPN, Open DNS, and then one of those is Cisco. I forget which one is which, and then 8.8.8.8 is there. Exunium, everything that I show you guys how to do inside of Grafana here, I have a project that shows you how to do it all. I have both the project and I have labs. So look, if you go here, if you go to our present projects in projects, and you scroll up, this was the first thing we ever did in projects here, was you come in here and here's our monitoring deep dive guide, our project guide, and here's our monitoring from when we did this. We did this a while ago. Look, 4/25/2023. We did a big project, and I had you guys come in and do all of your lab stuff. And here is it's right at the top here. Yeah, monitoring. You want to download these two guides, and then they walk you through the project of building everything out. And then we've got all our killer Coda labs that we built for it, and they show you how to build everything out. And then we did some specific like different logging with Loki for fun. And I show you guys how to do all that as well. So that's something to play with. That is a significant amount of hours. I'd say when we did it, we probably talked through it. Oh, that project is up on my YouTube as well. So when we did that project, people that want to see it, that's in our that's called the monitoring. I think it's called Monitoring Systems Exunium. So if you need help with that, that's how you do that. Yeah. That's how you go find it. It's on my YouTube somewhere. It's called that. I can go look it up real quick if you want. Hold on. I'll give you a link for it. Hold on. Let me go find my YouTube channel and then my videos. Oh. Apparently that is not its own video. So good that I checked that, because I've been lying to you guys. That's not its own video. Apparently that one never got uploaded like that. But here is the actual video called Monitoring Linux and Monitoring Project for Your Portfolio, Getting the Job and Systems. All right, so this is the one right here on Twitch side of thing. I'll post it on YouTube for you guys as well. But this is how you go and you build that out from our Discord if people want to do that. All right, so we didn't get through all of these, but these are jobs that I pulled out of the discussion for week 1 of our Linux class, and you guys could find things that are interesting to you. I'll keep going through this and adding more and hopefully giving more information, but the goal of this is to give you guys some confidence that we are talking about things that are actually in job requirements. Nobody knows everything. Sometimes you got to go reference things, and that's a good skill to have. But then we come in here and we find what people are looking for, and we figure out how to do that or even do it better for them in the systems world, right? Okay. So I'm gonna hop off of here. It's getting a little late. It's 10:30. Yeah, I got to go wrestle in the morning, so I'm gonna get off of here. But I will go to end of stream. We'll find somebody to raid on the Twitch side for anybody that wants to go get in on a raid. Let's see, who am I following that's on? I'm not following anybody that's on. We won't worry about a raid tonight. Cuddlingus, you're still here. You're supposed to go and do your labs. I'm just kidding. You can hang out. But